So we'll revise anyway. Today we'll see about closures. What is that? Closures. Closures in Python. Almost decorators and closures are once again one and same. Both are one and same. So based on the closures, I can say decorators can be understood very well. Or based on the decorators, like it's a vice versa. It's a vice versa. So both are in, what do you say, in same combination. Almost same combination. So means what you are expecting here? So when I say decorators and closures are same, what you are expecting here? So we are going to write function inside a function, right? We are going to write a function inside a function, and decorator reduces the lines of code as she told, and I can annotate this parallel, do a parallel business. Same. That's what the word I was expecting. I am doing some B1 business. I am doing a logging in. I want to maintain a login history. Then I will go for decorator. Okay. I am purchasing something in Flipkart. He is maintaining all my purchase orders. He is maintaining my, I am going and viewing some page, some item in a Flipkart. He is maintaining my view history. How he is maintaining my view history? So he is doing a parallel business. So you viewed, he has written a one service. And once again, you are just viewing, you're just visiting the page. He is logging the history log. He is maintaining a log. Who all has visited this page? So he will show you the customer who visited this page also visited these items. Right? So like this he will show. So how he is showing? Through decorators only. He is doing the business via decorators. The closure is also one and same. Okay. So now how we will write a nested function? We all know. We'll write a parent, and inside that we'll write a child, and we'll say return child. So instead of pass, we will do our own business, whatever we want. Either it may be insert or delete or update or something else. Right? So how we'll write a nested function? A function defined inside another function is called nested function. Right? A function defined inside another function. Right. So here you need to observe, we are going to see non-local variables. What is that? Non-local variable. What do you mean by non-local variable? What do you mean by non-local variable? A variable which is not in that function scope. Here if you observe, the value 22, value, actually the value is holding a value of 22, but it is being accessed where? In the scope of child. The value is defined in a scope of parent. It is being accessed in a scope of child, right? So it is defined here. It is being accessed here, right? It is being accessed here. So now the variables defined in the parent function that are used by child function, those are called non-local variables. Non-local variables. So tomorrow if someone says non-local variable, it should be like defined in another function and we are using in subfunction. Okay. Did you understand now? Any doubt here? No. Just I am declaring a value in a parent function. I am using in a child function. So that value is called non-local. Non-local. That's it. Non-local variables attached a returned function. So now, if you observe here, let us consider. I am writing a parent function. So what they call this as a closure. Okay. So now, if you observe here, the returning of a child function, right? They call it as a closure. What do you mean by that? If you return a sub function, okay, they call it as a closure. They call it as a closure. So now if you observe, so how we can see that closure, whether the closure is there or not. So now what we say, so now you observe here, we have defined a new function parent. What it will return at the end of the day, new function will be having a value of child function. So what is the child function is doing? My dictionary of chocolate is having, it will print, and it will print the value into 2 or 44 and argument plus 1 plus 2. What is argument 1 plus 2? 7, right? So shall we write the same program here and try? What is that? He is defining a parent function. What is the parent function? Define parent, which will take 2 arguments. Okay, we'll say argument 1, comma argument 2. Right. Okay, very good. So now what we have done? We are going to do value of 22. And once again, what we are doing? We are passing some. We are creating some dictionary. My dictionary. So we'll say so we have one dictionary. Now we are going to create another child one, so which doesn't carry any values. But what we are trying to do? We are trying to print the value into 2, and we are trying to print the my dictionary of Bangalore, and we are trying to access the value of argument 1 plus argument 2. So what we are saying? Return child, Baba. We are saying, okay, now return child. So now what we are doing? We are writing new func equal to what we are saying, parent of 10, 20. All right. So now what they are saying, if you call now new func, okay, if you call new func, what will happen? All the values will be printed in the child, whatever is there. So this is how we write. Listen. So now what she's saying, this particular part is called as a closure. So how we can observe this is a point. He's saying, so now we can access rather than printing that. So now we can access. So now what is saying? New func dot, what is that? Underscore. So now what he's saying, this is a closure. So now I have list of values, right? I have a list of, now what are those? 1, 2, 3. These values are there, right? So now what he's saying, so for that purpose, he is looping the data. So he's writing a list comprehension. Did you observe? He's writing a list comprehension. You need to observe that. So what is saying? New func. So new func of closure we have for every cell in this one. We need to prepare one. What is that? Cell contents. Okay, we'll take cell contents only. So what is saying? So rather than that, what we will do? We'll try to print first closure itself and see what is coming. We'll break the program into a number of pieces and we'll understand. So what is happening? It is giving you a cell content. What is the cell content it is giving you? So you observe here, we got a dictionary object also, we got a int object also, we got a value object also. Right? Clear? So now we have a closure inside this one. So now what we will do, I'll print a dir of new func. What do you mean by dir? It will give all the list inside this one. Oh, what are all there? So if you observe here, see here, we have closure also. So that we are accessing, right? That we are accessing. So now What is a closure now? If the function inside a value is returning a n number of values, these are all called closures. He's saying, okay, closures. He's saying. Now, what he's doing, we know that we have a list of values inside a closure. Now I want to access it. How I will access it? How I will access it? So rather than that, for I in new func of closure. So what I need to do? Print I will say. So now will I get the value? No. I got some addresses cell. So now, but what I want content. So cell underscore content. What is that? Cell contents. Clear? So it is taking argument 1 and argument 2 as a one cell. One or no, argument 1 as a one cell, argument 2 as one cell. So now we have how many? 4 cells, 4 cell values. Clear? So how I will access a closure value? So now tomorrow, if I want to access all the closure values inside a decorator or inside a closure, okay, right? So now what I'm saying is a decorator will have a closure. Are you clear? So how we are making decorator? So we are calling entire function. What do you say? A function within a function as a decorator. Now I'm saying a closure will be inside a decorator. What is a closure? A function which is inside a parent function. It's called a closure. And once again, we'll observe the. And once again, now we are checking. We want to verify. So what is our definition of closure? A function within the parent function. Now we have a parent function. We have a child function. Okay. Now I'm asking to return my child function, which is nothing but a function within a function. Okay, very good. Now what I'm saying, return a function, I'm passing the value. Now I'm checking whether my function is closure or not. Is closure or not? So what will be the answer? True or? True. Why? Because there is a closure. Obviously, this is a closure, right? Obviously, this is a closure. So now what is he doing? So now rather than that, what is saying that is not none. Okay, is not none. So it's giving you true. Clear? It's not none. Not none means, does this have any values? Yes, it has values. So then it is called as a closure. Okay, we'll check one another. Another one. What is that function? So I'll say func main. Okay, this is my main function. I'll say definition func sub function. Okay. I'm not doing anything, but I'm passing. So what we'll do? How we'll do? We'll say func underscore main. Okay. Now what we'll do? New func dot underscore closure. Excuse me, boss. Okay, written wrong, no? Why it is false? Why it is false? Why it is false? It's not returning anything. It's not returning anything. That's it. We are not returning anything. We are not doing anything, but we are expecting it as a closure. No, it's not a closure. If the value has returned to you, then it is a closure. So when should I write a closure? The first question, right? Will rise into our mind, right? When should I write a closure? Will rise in our mind. So we will see first. So this is our good example. Okay, we'll see one more example, then we'll go. So now, so we can check the length of the closure also, right? We can check the. So now you tell me what will be the length of the closure here? What will be the length of the closure here? Closure length 2. Why 2? No, previously we saw one example, right? This is a right. This example we saw. So now what will be my closure length here? What is my closure length here? 4. Okay. 4. 10, 20 dictionary and a value what we are doing, operation what we are doing, right? ಇವಾಗ ಅದೇ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ಕೊಂಡು ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್ ವಿಲ್ refer that and now we'll answer this. We'll refer that and now we'll answer this. So what is the length of the closure now? 2. That's it. Akka. That's it. No. Other than that, we are not doing any multiplication, and we are not generating any new thing here. Correct? So now you need to understand, if I have any new value, it is considered as a new content. New content. Clear? New content. So now from this example and previous example, you need to compare and understand. If I am going to generate a new value, it will be created as a new content in my closure. Right? So if it is not, it will be whatever the arguments you pass. If you don't pass anything, we have done, right? What is that? We have done another example here. We have done here, right? What is that? We are not passing anything, but we are trying to return, but it is not a closure at all because you are not getting any values. It's not a closure anymore, right? So what do you mean by a closure? A sub-function which returns you a value. A sub-function which returns you a value, not a value, not only a value, a list of values, a value or a list of values. Okay. We have done iteration in the format of what do you say, normal for loop. He has done using a range. That's it. He has done using a range. The example in the slide is doing same iteration only. He's doing same iteration only. What he is doing? He is taking the contents of a closure, okay, and he is pushing into closure values, list of closure values. That's it, right? So we have what we have done earlier. What we have done in a closure example 0, we have looped the closure and we have pushed into, we have printed out. What he is doing, the rather than that, is looping, thinking a range as 2, right? And he is creating a new one. So it's a new example I'm saying. Same only, another way he's doing. That's it. Okay, he's doing some bit difficult way. We have done some easy way. Okay, we have done an easy way. So one more. So can you guess the answer for this? Can you guess the answer for this? You need to guess the answer for this. So what we are doing, first of all, we are defining a special function. That is a parent function. Is it a parent function? No. Normal function. Normal function. My special function is a normal function. Okay. So now the immediate next, what we are doing, we are going to create a function within a function. Okay, very good. So now we have written get new function, which will take a function as a parameter. What is that? Any function as a parameter. Okay. For us, what is that function? We don't know. Okay. Now what I'm doing, so inside the sub function, I'm calling the function parameter. Very good. So this is what our generator does normally, right? So new function, get new function of my special function. So means you are running my special function should be the output. What I'm doing here is redefine my special function to print just hello. Okay. So now what will be your answer? Is the question. Hello. Okay. Guess model. ತಪ್ಪೇನಿಲ್ಲ. ಹೆಂಗೆ hello? Why it is hello? ಅರ್ಥ ಆಗಲಿಲ್ಲ. Okay, so now my question is whether it will run, you are running my special function or it will say hello. Two choice. What is your answer? And why? I'm just asking what is your answer. So at the end of the day, you call a function. What is your function parameter? My special function. My special function have two definitions. Have two definitions. Which output it will come is what I'm asking. Are you clear? Huh? Are you clear? Now, what is the answer? This time I'm asking you to guess. I'm not asking you to code. Okay, you are running my special function. Okay, let us see. Okay, what we will get. So how we need to define? We need to define one function first before to call. So we say define my special function. It will not take any parameter. So we will say you are running my special function, right? So now what is that? Next we need to have a parent which will take a function as a parameter, right? So now we have a child which will take again a function as a parameter. Illa parameter illengidrunu parvagilla. So but what we'll do, we will call a function and we will return a child. Array. Right? Now what we are doing? Now we are creating new func is equal to parent of what I'll say my special function. Okay, that I done. What I'm doing? I'm defining once more my SPC underscore function print So now what I'll do, I'll call a function, new function. So what will be your answer? Once again. Huh? Huh? You are running my special function only. Why? Because your definition is after the function call. Okay. So it's like you have been ordered to do something. After that, the order has been changed, but you started doing. Right? You have been ordered to do what? You have been ordered to do call my special function, and we went with my special function and we call my special function. What is the definition? It knows before to this up to here only this, but not this. Right? So shall we check whether the function is closure or not? Whether the function is closure or not? Okay. So we'll see. What is that? So what is your answer? Whether it is a closure or not? Huh? Whether it is a closure or not? Closure, huh? True, huh? True. True. Because it is returning something. It is returning something and it is doing something. Right? This is a closure. Right. So we will move on to the further section, further example. Okay. Let us consider. I am doing a function. Okay. What I am doing? After call, what I am doing? I am deleting my special function. I am deleting my special function. So what will be my answer? What will be my answer? I am deleting the function after call. After call, I am deleting the function. Still it will come. Why? Because the control is, the deletion is after the control. It was not before. So if you do before, again it will throw another. Right? So that you need to understand. Okay? Here is one more example. Okay. Okay. What is the answer here? What is the answer here? What will be the answer? What we are doing here? Are you able to see? First of all, what we are doing? We are defining a special function, and we are doing a sub function calls. Like we are preparing a get me function and call function. The call function will take the parameter of main function. Okay, very good. And call that function. Okay, very good. Now what he is doing? He is overriding and he is giving the value of my function. So nothing. I am overriding the behavior of my special function when I call. That also I can do. I'm saying. That's what we did in decorators also. Okay. So I can override my behavior until I override on the 10th line. What was my behavior? To print some statement, to print some statement, or to do something. Let us consider not only a statement, to do some X work, to do some X work. Okay. So now on a 10th statement, what happened? It became a function which calls a closure, right? Which calls a closure. So now if I say my special function is a closure or not, it say yes. It became a closure when on 10th line. Clear? Until that, it was a normal function. Until that, its behavior was to do something only. On 10th line, what we have done? We have modified the same to closure. Clear? it clear? And Shivani, artha aita? So what is the definition of a closure? A closure is a nested function which has access to a free variable from an enclosing function. Okay. So if I tell this, you will not understand. So now we have seen the n number of examples. Now we came into definition. Now we will have a clear idea. When we are reading itself, our mind will read. Okay, a function. It will draw a picture, illusion, right? So now what is he saying? Which has access to free variable from enclosing function that has finished its execution. That has. So what is the closure now? That a function which has access to a free variable from an enclosing function. Okay. So from an enclosing function, if I take a value, anything, means from a parent, if I take, then I am called as a closure. Then I am called as a closure. So what are the three characteristics of closure? It's a nested function. It has access to free variable in outer scope. Okay. It is returned from the enclosing function. Now, did you understand what is a closure? Where we are using this closure? In decorators. Right? So now we should learn closures so that decorators will be easy. So decorators was a bit difficult. Now let us go into them. A free variable. What do you mean by a free variable? A free variable is a variable that is not bounded in local scope. Okay. What do you mean by local variable? Non-local variable. A variable which is available in parent. Yeah. So now, in order for closure to work with immutable variables such as numbers and strings, we have to use a non-local keyword. Okay, fine. So now you need to understand one point. You read the last one before line. Provide some form of data hiding. I want to do some form of data hiding. Then I will go for closures also. Okay, you need to understand this. I need to do some form of data hiding. Okay, so the external people, they are reusing my function. Let us consider they are loading my module. Okay, I want to do some data hiding. Then I can go for closures. Clear? Then I can go for closures. So now we can write closures in a real-time scenario like this. I'm logging into my ATM. Okay, what I will do? Login is my function. Login is my function. At the end of the day, your statement should be welcome to my bank transaction, right? So behind the scenario, we'll write one closure, or we'll write one closure. Let us consider. So what I'm saying, so when I say some function called login, so now what I have done, I'm checking. I'll write a check function, parent check. Okay, parent check will take my login function. Okay, login function as well. So now what we are doing in login function, we are checking along with his PIN number, it came to us. Okay, or along with his account number, it came to us. So we have the details. This is account number and its PIN number. If both are matching, only we'll say your account login is successful. If it is not, we are not. Did you understand what I'm doing? Same way we can do. You can apply a closure rather than normal function. We can do a closure. So closure, if you do, what will happen? You will not know what is inside, right? What is inside? You will just call a function, but what is inside you don't know. So it's some form of data hiding. There we are. So attaching a non-local variables to nested functions. That's it. We have a variable and we are accessing to a child function, right? Child function. That is nothing but a non-local variable attaching to a nested function. So what it is saying? So if you observe here, a equal to 5 and print a. So now if you see, if I check the function type, if I check the function type of a function, class tuple it will be. What is that? Class tuple it will be. If I check a function of length, it will be 1. Why? Because only one variable it is returning. It is a printing. It's not returning, it is printing. It is doing some work. Okay. And function contents, how will I check? I know that using cell contents. Cell contents. Simple. Now we have seen bigger one and we have seen smaller one. Ah, the same he is doing again and again. Same he is doing again and again. So okay, simple closure example. What is that? We want to make printer with a message. Okay, message is hi there. Okay, so printer. Okay, define a printer. Print the message. Okay. Now if I say hello there, so what will happen? Whether it will come hello there or hi there. What is the answer? Good point. Good question. It went here, yeah? Man. So hope you people understood the closure point. Okay. Huh? So, and once again, it's very useful to us. We start to do what is hidden calculations. Hidden calculations from the outside world. So now what we are doing? We are taking a make print message. Okay. So what will be my output? Whether it is a hi there 3 times or hello there 3 times. Hi there, hello there. If you tell this, it means that you understood. Are you able to see? First of all, no. Okay, I'll write that function. So what is saying? Make print. Okay, so it will take some parameter. Okay, that is nothing but a message. What I'm saying, message is equal to hi there. Okay, so now there is my sub function. What is that sub function? I will say jail. So it will take what do you say? Okay, which will not take anything, and just it will print my message. And what I'm doing is I'll say return child. Okay, so now I'm saying my func is equal to what is that? Is make print or make print of hello there. And what I'm trying to do is I call my function, my func price. So what will be my output? What is your answer here? Whether it is a 3 times hi there or whether it is a 3 times hello there. Hello there. Yeah, very good. Hello there. Hello there. Hello there. Anyone hi there? Anyone hi there? Hi there or hello there? Hi there. Hi there. Very good. Hi there. Why? You are calling that function. Inside that function, your message has been modified. So you are sending hello there. My value will be what? Hi there only. I have modified the value right inside that. I'll take only the latest value. Why I take the parameter value? The parameter value is set as hello there. Okay, for me. But I am inside. I am what I'm doing. I am doing the modification. No, huh? Right? You got my point? Inside what we are doing, we are changing the value of a parameter. Okay? Understand? Simple. Nothing big we are doing. Very good. So definition of a closure. Yeah. When do we have a closure? We have a closure in nested function. The criteria must be met to create a closure in Python are summarized as below. We must have a nested function, a function inside a function. Okay. The nested function must refer a value defined in the enclosing function. Okay. Must refer to the value in parent. The enclosing function must return the nested function. So when to use closures? What are closures good for? Okay. When should I use closure? Is the question. Closure can avoid use of global variables. So some of the global variables, if you are trying to use, okay, we can avoid that and provide some data heading as we discussed. Okay, you can provide an object-oriented solution to the problem without going to the classes and objects. We are achieving the objective of object-oriented data heading. Data heading. So we know object-oriented. We were doing class and we were doing data heading and all. We were achieving the data heading encapsulation information and all. Rather than that, what we are doing now, we are achieving the same goal with the closures. Right? Same goal with closures. So when there are few methods or one method in most cases to be implemented in a class, closure can provide an alternate or more elegant solutions. Okay. But when number of attributes and methods are larger, better implement classes. You have a huge functionality, then go for oops is saying. So you have a less functionality and you want to do a data hiding and all, then you go for a closure is saying. Clear? Okay. So here is a simple example. A closure might be preferable than defining a class, making object, but preference is always. So that's what the preference is up to you. How you define as a developer. Up to us, first of all. So whether I should go for a closure, whether I should go for a object oriented. It's up to us, in between us. Clear? Atta, Aita. Okay. Right. So that ends the closure. Okay. Thanks. Next again tomorrow we'll have